You're going to like this lesson. It's very short. This is just about reasoning strategies, sort of not exactly brain teasers, but kind of. These problems are going to involve just using logical reasoning. Now remember, the problem-solving process is always the same here. We're going to understand what the problem is. That means you better take a little time and read the question carefully. Develop and carry out a plan. That's the heart of it, isn't it? Sometimes that's the part we jump to first before we understand what the question is really asking, so beware. And then this last part we sometimes forget too. After we found the answer, we should check it. One of my favorite ways to check it is to ask the question, does it make sense? If it doesn't, well, go back and try again. Reasoning strategies. Actually, in today's lesson, all we're going to do is this little 5-minute warm-up, and then we'll talk about all the reasoning strategies there are. So it should be fairly short, which I think I owe you because some of the others have been maybe a tad on the long side. Okay. Number 1, lines are drawn connecting each corner of the cube. Here we've got the cube with, how many corners does a cube have anyway? Well, if we think of it as the top face and the bottom face here, we can account for all corners by looking at this and see we have 4 corners on the top and 4 on the bottom. So we've got 8 corners. How many lines are drawn in order to connect all these corners? Well, here's where you want to just organize yourself. Organize. Figure out a way to look at this methodically. Well, I'm thinking if we look at all the edges that define this top and all the edges that define the bottom, then all we have to do then is figure out how many lines do we have connecting the top and the bottom. That would account for all of it, wouldn't it? Well, connecting the 4 corners at the top, we have 4. Connecting the 4 corners at the bottom, we have 4. Connecting the top and the bottom, we have another 4. So we're up to 12. Let me go back to my question, make sure I read it carefully. Lines are drawn connecting each corner of the cube to every other corner. Well, of course, what I just didn't connect every other corner. It only connected the corners that would form the edges of the cube, right? So I've got 12 edges. What else would I have? Well, I could be going diagonally, if you can kind of picture this, diagonally across the cube to this one here, and then I could be going diagonally across the cube to this one here. Of course, it should be a straight line. I'm sorry about that. Oh, it's ridiculous. I could be going across the cube from here up to here, right? And I could also be doing that here. So I actually found 4 more lines that would be diagonals, haven't I? Lines are drawn connecting each corner of a cube to every other corner. How many lines are drawn? So I think I've got another 4 that would be diagonals through the center of the cube. Gee, what else would I have? Can you think of anything else that I might want to think about here. I'm going to cross this out while just make it clean again. So I accounted for all these connections that we see that make the cube. I've done diagonals across the inside. Oh, what about diagonals on each of the faces? There'll be 2 diagonals I could draw on each of the faces too. And how many faces do I have? Well, I've got the top and the bottom, the front and the back, and the left and the right. So I've got 6 faces. Wow. Oops, I erased one of my 4s when I did that. So that would be 2 times 6, or 12. So what am I up to now? 28? 28 lines, can that be it? Have I forgotten anything? All right, let me record my answer here, and I'll go back and read the question again. Lines are drawn connecting each corner of a cube to every other corner. All right. I can't resist looking. I have to see. What did I figure out last summer? Good! I figured it out again! All right, 28 lines. Well, you see how that was. It's really kind of a brain teaser. These are fun. I like these. So in this first one, what helped was we already had a diagram drawn, and then we started looking at it logically. We went back to the question, make sure that we have in fact answered the question, and of course I found that I hadn't. I'd forgotten about some other lines. Okay, we'll go to number 2. How many different sets of positive integers have elements that total 5? Okay, so I'm going to read this problem carefully. I've got positive integers only. That helps. And because it's positive, it means they are no negatives and no to 0 as well, right? I can't have any negatives. I can't have 0. So elements that will total 5. Well, let's keep it simple. If I had 1 plus 1 plus 1, I just stop when I hit 5. That's one set. Oh, this would also be a set, wouldn't it? Just the 5 all by itself. You can have a set that only includes one element. Doesn't say here that we have any restriction on the number of elements. The only restriction we have is that when we add them together, total, when we add them together, it has to equal 5. So 5 equals 5. So that's 2 of them right there. I am going to leave the rest to you, and you should come up with 7. Why don't you pause it right now and see what you come up with. When you come back, I'll show you the answer. Okay, here you are coming back, so let me, here we go. There they are, 7 sets. Gee, I hope I didn't forget any. Well, if I did, please let me know in class. I think that's as many as we could possibly do. Here are a whole set of reasoning strategies. Just take a minute to look at these. Some of these we've covered earlier in the year. Almost always we end up writing an equation, but it is actually not always, because we just did 2 where we never wrote an equation. But this is a very common strategy to write an equation. Lots of times we have to mix strategies. We want to write an equation, but in order to figure out what the equation is, we do other things like simplify the problem, make an organized list. In Chapter 3, we had made an organized list. In Chapter 8, the one we're in now, these problems just involve logical reasoning. The very first chapter in the book, you were drawing a diagram. In Chapter 6, you were making a table. We haven't gotten to Chapter 10 yet, but when we do, you'll be simplifying the problem. That sounds good. That sounds really good. I like that. We can take something and make it simpler. Oh, what do we often call this one here? Guess and check. Very low grade problem solving, but if it helps you get through a problem quickly and you're working in a standardized test situation, do it. Guess and check. Yeah, sometimes that's the quickest way to get your answer. So if speed matters and you think you can guess it, go ahead. Look for a pattern. That's actually what mathematics is all about. It's all about finding the pattern and then coding it into an equation. Usually these equations are just representing some pattern that we saw in a phenomenon about us. Working backward. If you have some idea where you're headed to, sometimes you can work backward to figure out how to get to that answer. And of course, very commonly, we combine strategies. So there it is. And I am very pleased to tell you this was a 12-minute lesson. So enjoy your time. You deserve it.